Hi, I'm Paul. We are doing Leetcode must know interview questions. Today's challenge is combinations, medium rating, given two integers n and k. Return all possible combinations of k numbers chosen from the range 1 to n, and you can return the answer in any order. What does that mean? Well, for example, if n is 4, then that means we want to deal with numbers from 1 to 4. And we want to take them 2 at a time. We want combinations of 2. Okay, so you can see everything in here in the output. Here are all the possible combinations. Combinations are unordered, so 1, 2, and 2, 1 are the same combination. What else? There will be at least, well, n will be at least 1, and k will be at least 1. All right, how are we doing this? Well, the topics here are backtracking. Okay. The last challenge we did, what was the last challenge? Oh, it was letter combinations on phone numbers, something like that. That was also a backtracking problem, and I have to admit that I implemented it as not a backtracking problem, just well, just as a breadth first search problem. And what I got was it ran in 6 milliseconds, which was like the worst time. Some people were getting it to run in like 1 millisecond. I rewrote that to do it with backtracking, and it actually didn't improve. It actually didn't improve the runtime. Well, maybe it did a little. I think it went from 6 milliseconds to 5, but maybe it's a problem with the way I'm writing backtracking algorithms. I guess we'll find out. But I mean, what we're doing here in terms of backtracking, all right? We will write a recursive backtracking routine and then start it off by calling it with the number 1. Okay. The backtracking routine will recursively call itself with the next number, which is 2. As we do that, every time we call the breadth first search algorithm, the depth first search algorithm, we'll add the number that we call it with to a combination. So we call it with 1, we add 1 to the current combination. We call it with 2, we add 2 to the current combination. Next, we'll call it with 3. But the first thing we're going to do when we call that routine is we're going to check and see if we already have a current combination that is of the right length. So when we call the depth first search with 3, we've already got a combination of 1, 2. So we'll take 1, 2, add it to the result list. We'll also backtrack and take the 2 off. So now we have room for the 3. So we put the 3 into the current combination, and then we call depth first search with 4. First thing we do when we call depth first search with 4 is we check and see, do we have a combination of length 2? And we do. It's 1, 3. So we take 1, 3, put that in the output list, and backtrack to 1. So now we have room to make a 1, 4 combination. So we make the 1, 4 combination, and we call back DFS with 5. All right, so then a couple things happen. One is we notice that we have a 2-element combination, 1, 4, put it in the output list. We also notice that we've gone too far. We've gone past the number of numbers that we really want to consider, which is 4, and we just called it with 5. So at that point, we have exhausted all the possibilities of the number 1. So the recursion unwinds back down to 1, and then we call DFS again with 2, and we've taken everything out of the combination. So it starts over again, and you can see it builds up to 2 3 2 4 3 4. Anyway, that's how it works, and let's look at an implementation. All right, there are some things here that are going to be useful to have as class variables. One would be, because we're gonna have two methods here. So one would be the list that we're going to return, which is a list of integer lists. Call that what are we calling it? Oh, combinations. Just call it combos. And that is a new array list. All right, the second thing, actually kind of close to this, is we need the current combination that we're building up. Okay, we'll also build that up as a list, and so that we don't have to pass n and k back and forth all the time, let's set those as class variables, private int n and private int k. All right. So starting this out, combine, let's set this dot n equals n, this dot k equals k. We are going to return combos, and where the work is going to be done is right here. We'll call, I don't want to call it backtrack or DFS. I think I've been kind of, it's a depth first search. Let's call it DFS. And start with 1. All right. Private void. This doesn't have to return anything. We can use the class variables. Private void DFS int will be I could call it I, but maybe there's something better. Int. I could call it I. We're just using numbers from 1 to n. So I guess I is okay. All right. So a couple of things that I said that we have to check when we start this. One is if the current combination size is equal to k, then that goes into the result list. Combos, add, new, array list. Do I need to do that? Cur. I guess I do. You know what? It's not like that. It's like this, because I need to keep a copy of. I need to keep a copy of cur. I don't want to just put pointers in the result list. So we'll create a new array list and keep a copy of what we have so we can use it for backtracking. All right. Once we've done that, we're going to return. Okay. The other thing we need to check is if I is greater than n, then we have exhausted the possibilities of I, and we just return. Okay, if we get past those, we will take current and add I. And then call again the DFS with I plus 1. I'll kind of walk through this a little bit before we try to run it. Okay. When that comes back, we need to backtrack. And part of the backtracking is current remove current dot size minus 1. So remove the last element of the current combination. Okay, and then call DFS again. I mean, that's a little awkward, but we have to do that. All right, how is this going to work? Again, let's kind of start at the beginning. We're going to call DFS with 1. So 1 comes in here. Is the size equal to k? No, actually, at this point it's just 0. Is I greater than n? No, it's 1. So we go down here, cur add. So we add 1 to the current combination that we're building out. And then we call DFS 2. All right, so DFS 2 comes in here. Is the size of the current combination equal to k, which is 2? It's not, it's just 1. Is 2 greater than 4? It's not. So we add 2 to the current combination, and then we call DFS 3. All right, we come in with DFS 3. Is the current size equal to k, 2? And it is. We have the current combination is 1, 2. So we are going to add 1, 2, the list 1, 2 to the output list and return. And so we're going to return from here. Now we're going to remove the last element of the current combination. Current combination is 1, 2, and we are going to remove the 2 and then call DFS with 3 again. It's kind of like one call, but we have to split it into 2 calls like that. So we call DFS with 3 again. Current size, it is now 1 because we removed the 2. So we go past that. We go past this because 3 is not greater than 4. And we add 3 to the current combination. 1, we have 1, 3. And then we go ahead and we call DFS with 4. And so that's the idea of how this proceeds. That's why we have the DFS, the 2 calls in here to DFS, sandwiched around a remove of the last element of the current combination. Am I forgetting anything here? I think this is worth a try. Let's do it. Compile error, DFS1, it's right here, semicolon. All right, base cases work. Scoot that over, we can see the whole thing. Submit. I know this is not going to be fast. Okay, so we're in the middle, like about 50%. It looks like most people are right here, 18 milliseconds. What did we have? Whoa, wait a second. Oh, I'm sorry, I'm looking at memory. We had 21. We had 21. All right, so looks like 18 is the score to beat here. Analyze the complexity. Okay, I mean, so you have n numbers, and for each number, you have the option of picking it or not picking it. So we go through and we say, well, number 1, all right, we'll take that. Number 2, we'll take that. Or, we don't take that and we'll take 3. Or we don't take 3 and we'll take 4. Or we don't take 1, but we'll take 2. So it's kind of like 2 to the n, but then on the other hand, if there's a way to, it's either 2 to the n, or, it's a binomial coefficient like this, 4 choose 2. So 4 choose 2 is, what is it? It's n factorial over k factorial times n minus k factorial, which in this case is 4 times 2, 4 over 2, 4 factorial over 2 times 2. Cancels out the 4. We get 3 times 2. It's 6. So it's got to be one of those. Anyway, how do we get back to? Oh, here we go. Yeah. So what is the complexity of this? 2 to the n. Oh, okay. I don't know. I'm not sure that's exactly right, but yeah, maybe it is. Maybe it is. Okay. Anyway, that's it for combinations. Hope you enjoyed it. Please feel free to like, subscribe, comment, and see you next time.